Here it is given that we have an engine of a car which is exerting a constant driving force as the car accelerates from rest. And we are supposed to find the graph between power and the distance traveled by the car. Since the y-axis is power, let's start with the basic formula for power. We know the basic formula for power is work done per unit time, which also can be written as force into velocity. It's mentioned here that the driving force is a constant, so F is a constant. Now observe in the graphs S, the distance is the x-axis. So we will have to incorporate S into this entire expression. So how do we do that? We will use the Stewart equation V square equals to U square plus 2AS. In the question, it's mentioned that the car is starting from rest. So initial speed U will be 0 and 2AS V square. Now let's make V as the subject by taking the square root. We'll get 2AS. Now let's put V in the expression for power. We'll get power is equal to force into square root of 2AS. And how do we find acceleration? We use the Newton's second law, the force divided by mass. Hence, the entire power expression becomes F into square root of 2 F upon m into s. Now observe in the right hand side of this expression, F is a constant, m is a constant. So which means we can write power P is directly proportional to root s. Now all we need to do is check which of the graphs satisfies. Let's analyze all options one by one. Option A is the graph for y is equal to root x. Option B is y is equal to x squared. Option C is y is equal to a constant, k is a constant. And for option D, the equation is y is equal to mx, where m is the gradient. Now, since we were supposed to do power is directly proportional to root x, which is y is directly proportional to root x. So the only option which satisfies that is option A. So A is the answer to this question.